Hello students, today is the 9th lecture session, part 1. Topic of the lecture: Internet. In this video, we will cover the following topics: Introduction, a brief history, Internet structure, who manages the Internet, and manages trunk channels, modern Internet governance structure, network information service providers, national information infrastructure, organizations related to the work of the Internet, Internet culture, advantages and disadvantages of the Internet, conclusion. Introduction. The Internet is a worldwide computer network that unites millions of computers into a single information system. The Internet provides the widest opportunities for the free receipt and dissemination of scientific, business, educational and entertainment information. The global network connects almost all major scientific and governmental organizations of the world, universities and business centers, information agencies and publishers, forming a giant data warehouse for all branches of human knowledge. Virtual libraries, archives, and news feeds contain a huge amount of text, graphics, audio, and video information. A brief history. American scientists Vannevar Bush and Theodore Home Nelson were looking for ways to automate human mental activity. They wanted to save him the tedious task of finding and processing the necessary information. Bush even came up with several hypothetical devices that organize associative connections in the data file, and Nelson developed the theory of a documentary universe, in which all the knowledge accumulated by mankind would represent a single information system, riddled with billions of cross-references. The work of these scientists was more philosophical than practical, but their ideas formed the basis of what we now call hypertext. Vannevar Bush did a lot to get the military interested in science. The generous funding of research in the field of cybernetics undoubtedly contributed to its rapid development. Norbert Wiener played a significant role in shaping the theoretical basis of the future global information system. His brilliant seminars at the Massachusetts Institute of Technology attracted many talented young people to the computer industry. In the late 1950s, the U.S. Department of Defense established the Advanced Research Projects Agency, ARPA, which was engaged in computer modeling of military and political events. Talented organizer and computer scientist Joseph Licklider convinced ARPA management to focus on the development of computer communication and networks. In his work The Symbiosis of Man and Computer, he developed the ideas of distributed computing, virtual software, electronic libraries, and developed the structure of the future global network. In the 1960s, computer networks began to develop rapidly. Many development companies created software and equipment for local networks of universities, research centers, and military institutions. However, when transferring information between different types of networks, there was a compatibility problem, when computers simply did not understand each other. A major disadvantage of large networks was their low stability. The failure of one section could completely paralyze the entire network. The ARPA agency was tasked with solving these problems, and the time has come to implement the theoretical developments. Paul Baron, Larry Roberts, and Vint Cerf developed and applied the methods that became the basis for the further development of network technologies, packet switching, dynamic routing of messages in a distributed network, and the use of a universal network protocol, that is, a set of rules by which information is organized and transmitted. In 1969, the ARPANET network was created, which became the basis for the future of the Internet. 1969 is traditionally considered the year of its origin. In 1976, CERF developed the Universal Data Transmission Protocol (TCP/IP), Transmission Control Protocol/Internet Protocol. The name IP simply meant the Internet Protocol. It became the standard for internetwork communications, and the networks using it were called Internet networks. ARPANET became the basis for combining local and territorial networks into a single global system, which gradually grew to the scale of the entire Earth. This is a giant combination of networks and is called the Internet with a capital letter network. In the 1980s, the Internet was used mainly by specialists. Email was transmitted over the network and teleconferences were organized between research centers and universities. In 1990, Tim Berners-Lee, a programmer at the European Center for Nuclear Research in Geneva, created a system that implements the idea of a single hypertext space. For the description of hypertext pages, a special email language, hypertext markup language, was used, and for their transmission over the network the HTTP transfer protocol, hypertext transfer protocol. A new way to specify addresses using URLs, Uniform Resource Locator Universal Resource Index, made it easier to remember them and better navigate the information space of the Internet. A special program for displaying hypertext pages, the first browser, was also written. Berners-Lee called his project the World Wide Web, that is. But the Internet became really popular after the release of the graphic browser Mosaic, developed in 1992 by an employee of the University of Illinois, Mark Andreessen. By this time the network bandwidth had increased, and it was possible to quickly transmit color images, photos, and drawings. The Internet was flooded with not only scientific, but also entertainment information. The number of network users and the amount of data available grew at an unprecedented rate. By this time, Internet governance had been transferred to the private sector and had assumed a de facto advisory and registration character. The history of the Internet is rapidly developing, and one can only guess what surprises modern digital technologies will bring us. But it is safe to say that we are entering a new phase of human development, the information society, and the Internet will become an integral part of it. Internet structure. In the early 80s, all research networks connected to ARPANET already used TCP/IP protocols, and ARPANET for the nascent Internet network began to be a backbone network, providing a physical connection between the most important nodes. The process of transition of individual networks to the TCP/IP protocols was actually completed by the end of 1983, and a new network was born, the Internet. When the Internet took its first steps in its existence, there were only 213 registered host computers. Host computers, or hosts for short, are computers that are connected to a network and provide various types of network service. By February 1986, the number of hosts had increased to. Today, the Internet is experiencing a period of explosive growth, and the number of host computers in the world is already several tens of millions. Who manages the Internet? In the usual sense, the Internet does not belong to anyone. The work of backbone communications located in the United States is funded by the National Science Foundation, NSF, National Science Foundation, and the main issues related to technical support are resolved by the Internet Engineering Task Force, IETF, Internet Engineering Committee. The IETF is a public committee in which the efforts of scientists and experts are aimed at solving technical problems and related issues of further development of the network. There are national and international Internet segments that are funded from various sources and managed by their own administration. However, they all recognize the solutions and standards approved by the Internet Architecture Board (IAB). It is also a voluntary organization consisting of a group of invited experts. Anyone who considers themselves able to help solve the issues discussed can take part in the process of developing and approving Internet standards. IAB decisions are communicated to the online public through the publication of documents called Request for Comment (RFCs). Some of these documents are dedicated to network standards, but in most cases they describe new technical ideas and stimulate discussion about the future of the Internet. RFCs documents are stored on many Internet host computers. You can get acquainted with their content using one of the types of Internet Service Anonymous (ARIT) file transfer protocol. For example, RRCART's files can be found on an ICT server with the address Internet. You will learn a lot about the Internet by reading the RRX of information content, which are also called for your information. These documents will help you get acquainted with many aspects of the Internet, including a glossary of basic terms, issues of the culture of relations in the Internet. You will also find answers to frequently asked questions. ENSF manages trunk channels. In the mid-80s, the National Science Foundation created several supercomputing centers located in different parts of the country. In order to enable universities and other research centers to remotely access supercomputer resources, ENSF has established a new ENSNET backbone network connecting supercomputer centers, and is also funding the connection of regional networks to it. By the end of the 1980s, MERIT, a consortium of Michigan educational institutions, was awarded a contract by ENSF to upgrade, maintain, and manage the ENSNET network. In the early 90s, MERIT received proposals for commercial use of the Internet. Initially, ENSF was opposed to the growth of commercial network load, created for educational and research purposes, but later a compromise was found, to direct the revenue from commercial traffic to the development of national and regional network infrastructure. Modern Internet governance structure. The process of entering into new contracts between ENSF and other organizations to manage the ENSNET network continues now, as the current 5-year contracts are nearing completion. As Internet usage has increased significantly due to the connection of commercial organizations and individuals, ENSNET management practices in the future will differ significantly from today's rules. For ENSF, the new ENSNET network configuration is represented as a set of separate networks connected to a single high-speed backbone. According to this concept, regional networks will pay for connecting to the backbone, and educational institutions and commercial firms will, in turn, pay for connecting to the regional network. In contrast to the previous practice, when the ENSF directly financed the existence and development of the network, regional payers will themselves finance projects for the development of the network. The ultimate goal of the ENSF is to withdraw from direct funding of the ENSNET network altogether. Network information service providers. In April 1993, ENSF signed 3 5-year contracts with a number of organizations to manage the network information service. The holders of these contracts jointly manage the work of INTERNIC, Internet Network Information Center, Internet Network Information Center. They are responsible for providing information about the rules for connecting and working on the Internet. Network Solution was chosen as an organization that deals with the registration of new networks, including the assignment of IP addresses, unique codes that identify any computer on the Internet, and the registration of domain names. AT&T became responsible for maintaining lists of ICT servers, other types of servers available on the Internet, for maintaining alphabetical and subject indexes for searching resources, library catalogs, and data archives. AT&T also offers services for creating databases, managing and maintaining information resources available to the Internet user community. Finally, General Atomics began to support the Network Reference Desk, which contains general information about the Internet, and to offer educational services. National Information Infrastructure. Imbued with the importance of creating a national information infrastructure, the US government established funds to finance the development of a high-speed network built using the most advanced means of communication. This network is a research project that demonstrates cooperation between government and industry and aims to further develop network technologies. By promoting the development of a reliable, widely used network, the US government is committed to supporting the commercial development of network technology and service. The importance of the development of the US information infrastructure for education and the national economy can be compared with the development of the main highway network carried out in the 50s. Eventually, connecting to the information superhighway should become as universal as using a regular phone today. Superhighway will provide access to information about the services of commercial enterprises, electronic online versions of printed publications, commercial databases, public information, such as library catalogs and documents published by the government, as well as many other information services. Access to the universal network will contribute to the development of the concepts of remote communication, using the network to access information when working at home, participating in teleconferences, etc., and distance learning through bidirectional video teleconferences, supplemented by video materials and multimedia training manuals. Commercial firms have already started receiving orders and customer feedback via direct email, as well as distributing marketing materials and information about their new products through online services. All financial transactions can also be conducted online, eliminating the need for cash. As a result, the information superhighway can significantly change the way of life of the entire society. Some of these services are already available through commercial online services, such as CompuServe, Prodigy, America Online, but the possibilities of accessing information using a universal network, such as the Internet, are truly limitless. In addition to education and business, the network may have public forums that connect millions of people around the world and allow them to learn about other cultures and exchange information on topics of mutual interest. Organizations related to the work of the Internet. There are quite a large number of organizations whose members are engaged in training on issues related to the Internet, or research issues important for the development of the network. Let's list some of these organizations. Corporation for National Research Initiatives. The Corporation for National Research Initiatives, CNRI, is a non-profit organization established to promote cooperation between government, academic science, and industry in the development of a national data network. CNRI manages many research projects, including the creation of high-speed communication lines capable of transmitting live video and graphic images, and special computer programs (NoBots), which, like good computer viruses, will search for information of interest to the owners of these programs. Internet Society. The Internet Society (ISOC) Internet Community is also a non-profit organization whose activities are aimed at promoting the use and development of the Internet, distributing training materials and organizing forums dedicated to discussing various issues related to the Internet. The Internet Society serves as the Secretariat for the Internet Engineering Task Force and the Internet Architecture Board. ISOC organizes annual conferences, symposia on current topics, and specialized seminars. In addition to these functions, ISOC supports organizations whose activities are related to data security issues and user training. Computer Professionals for Social Responsibility. The activities of the organization Computer Professionals for Social Responsibility, CPSR, Computer Professionals for Responsibility to Society, are related to ethical issues of the use of computer technology. Established in 1983 to address the issues of stable and reliable operation of military software, CPSR has subsequently expanded its range of interests to many topics related to the social aspects of the computerization of society. Here are some of them. The right to the confidentiality of private information, such as medical records or tax matters. Reliability of software that controls life-threatening production processes, such as the operation of nuclear reactors. Issues related to the use of computers in production, especially those related to the replacement of people with computers and the protection of nature in the production and use of computer equipment. Electronic Frontier Foundation. The Electronic Frontier Foundation is another organization whose field of activity is related to the social problems of introducing computers into society. EFF members pay considerable attention to improving the legal aspects of the rights of computer users, since most laws do not recognize legal equivalence in the use of electronic means of communication in comparison, for example, with regular mail. The EFF aims to help achieve an understanding of the public importance of the new era of electronic communications. Internet culture. When scientists first began to study the problems of the development of the global network, there were several ideas about what such a network should be and what its possible dimensions would be. The developers of ARPANET believed that the network should serve as a collaboration in research and scientific activities, providing scientists with the opportunity to easily exchange information or use the resources of remote machines. Some of the creators of the network were surprised when email later became one of the most popular services of the ARPANET network. Advantages and disadvantages of the Internet. Inappropriate behavior is provoked by violent online games. Conclusion. The Internet today does not just exist, it is an integral part of human life. If it had stopped functioning for some reason, it would have had disastrous consequences. Then many vital processes for society would stop. It would not be an exaggeration to say that stopping information processes, a significant part of which is carried out through the World Wide Web, would also lead to a freeze in the life of society as a whole. Here, by the way, the answer to the question of the need and prospects of the network is already beginning to be traced. Thank you for your attention. Goodbye.